Hello, I'm Dr. Christyl Johnson, the Deputy Center Director for Technology and Research Investments at NASA's Goddard Space Flight Center. In this role, I'm responsible for shaping our missions of the future in astrophysics, earth science, heliophysics, and planetary science, and then establishing a portfolio of technology investments to enable the missions of the future. I love this role because every day for me is what I like to call visioneering. Establishing a vision of the future and then working backwards to figure out which barriers need to be removed and what gaps need to be filled in order to achieve that vision. Over the past couple of decades, the global community has had a vision of sending humans to Mars, not just for a quick visit, but to have a sustainable presence there. So if you'll just humor me for a moment and envision with me that we've traveled a few decades into the future, when we'll have the ability to not only survive, but thrive on another planet. Envision living on Mars after the first humans arrive, set up the infrastructure that'll support communities and even cities with significant populations. And then working backwards from that vision, there'd be so many challenges that would have to be overcome to even have a chance of making that vision a reality. For example, creating streamlined, long-duration radiation exposure spacesuits and above-ground habitat materials that could shield humans from extremely high levels of harmful space radiation that will also handle extreme temperature swings. Because once we leave the protection provided by the Earth's magnetic fields, its atmosphere, and its radiation belts, we're exposed to the sun's full radiation spectrum and all of its damaging effects. Mars has no global magnetic field to deflect energetic particles, and its atmosphere is much thinner than the Earth's, so we'll only get minimal protection even on the surface of Mars. This protection is so important because occasionally giant explosions called solar flares occur on the surface of the sun and release massive amounts of energy out into space in the form of X-rays, gamma rays, and streams of protons and electrons. This is called a solar particle event. And these solar flares can have serious and even deadly consequences for humans and their equipment on the surface of Mars and even traveling to and from Mars. In order for us to thrive on any other planetary body, we'll have to move beyond just watching the sun and giving people short notice to take cover. We'll have to work hard to better understand the mechanisms that cause these solar eruptions so that we can accurately predict them, because you certainly can't predict something that you don't understand. So the global heliophysics community is already analyzing data from past and current missions and designing missions of the future to address this challenge. But even after we develop the new materials for those suits and the habitats that have been tested to survive long periods of extreme space radiation exposure, and we're finally able to predict those solar eruptions, we'll still have to address the communication challenge in order for those innovations to be effective in protecting our citizens on the surface and during travel to and from Mars. Right now, here on Earth, we've grown accustomed to getting information immediately. And that's because we've established an infrastructure with communication satellites, with GPS satellites, repeater towers, and more. And we still experience dropped coverage, weak signals, and slow data transfer speeds on occasion. Now envision an interplanetary internet, where not only do we have to communicate and transfer information from one coast to another coast in one country, or from one country to another country, but now we're going to be transferring information from one planet to another planet. And I believe that we will always have that expectation that we will be able to get information almost instantly. So imagine all of the inventions that will have to happen to make that a reality. Before traveling to Mars, all the way to Mars, let's just envision for a moment what will be necessary to prepare for communications with humans who have a sustainable presence on the surface of the moon. We'll have to install sort of a LunaNet, which will require a constellation of satellites to be placed around the moon using multiple possible options to communicate back to Earth. One possible scenario would have them all to communicate directly back to Earth when their rotation is in orbit in the line of sight with the Earth, or maybe they'll communicate with each other and one of them sends a signal back down to Earth, or perhaps they'll all communicate to a relay, whether that relay is on the surface of the moon or an orbiting relay that processes that information and sends it back to Earth. We also need to go beyond laser or optical communication, which right now already transmits data at rates 10 to 100 times better than radio systems, and then ultimately using long-range quantum communications to achieve capabilities that are arguably impossible using classical methods. Once we have this kind of communication infrastructure, we'll be able to see the mechanisms that predict the solar eruption, send it to the LunaNet to be processed and sent down to the surface of the moon, and then be registered on a handheld device or a heads-up visor, warning the person of the solar event and giving them ample time to get to the closest safe shelter. But following that train of thought just a little bit further, how will the person know where the closest safe location is so that they can get there quickly? Well, there'll have to be a navigation element to this LunaNet. And when most people think of navigation, they think of GPS. But now, I'd like for you to envision that we've gone beyond GPS. Right now, our GPS system has about 31 satellites orbiting the Earth, and contact with at least 4 of those satellites is necessary to determine your exact location. The logistics of establishing a complete communications capability, along with GPS for each planetary body that we explore, would be a nightmare. So, what if we considered, at least for the navigation piece of the system, not even using satellites? Yes, I'm saying a GPS system with no satellites. What if we use neutron stars to help us navigate? I know some of you are thinking, what the heck is a neutron star, and how in the world could we use one of those to navigate? Well, neutron stars are formed in the supernova explosions that mark the end of life for some stars. We know that they're small and extremely dense. They're the size of a city, yet the mass of 2 suns compressed down to that small star. A neutron star emits beams of electromagnetic radiation out of its magnetic poles. But we can only see this light when a beam of emission is pointing directly towards the Earth, kind of like a lighthouse. That's why it looks to us like pulses of light, thus the name pulsar. They're the strongest magnets known and can spin hundreds of times per second. And because of their predictable pulsations, pulsars can provide high precision timing, just like atomic clock signals supplied through the GPS. So instead of using GPS satellites for local navigation on and between planetary bodies, where the signal gets weaker the further we go from each planetary body, we could use these pulsars for interplanetary navigation. That would eliminate the need to build so many satellites and insert them into the proper orbit, and the need to replace those satellites at the end of their useful life. Fortunately, pulsars have lifetimes ranging from hundreds of thousands of years to millions of years. And there are currently over 2,000 known pulsars with the potential of hundreds of thousands of additional ones in our galaxy. So we could easily find 4 or more of those pulsars to pinpoint location and enjoy very precise galactic travel. So I've given you just a few examples of the visioneering needed for humans to thrive on Mars, but there are so many other challenges that will inspire visioneers around the world to create the necessary solutions or inventions. But now coming back to the present day, there are people debating daily about whether or not we already have the technology necessary to go to Mars. Some say it will be 10 or 20 or even 30 years. People are also debating whether or not humans should even venture to Mars and what our objectives would be in sending them there. So now I'll leave you with just one thought. No matter what the objective we as a global community have in sending humans to Mars, and no matter how long it takes us to establish a clear vision and then achieve it, One of the greatest parts of this journey will be all of the impossible feats we as a nation and a global community will have to overcome in order to succeed. We'll have to advance some technologies and invent completely new ones. And while inventing technologies for impossible goals, we will inevitably find that some of those technologies that fail to meet our requirements turn out to accidentally provide revolutionary improvements in the capabilities right here on planet Earth. Thank you.